When it comes to understanding the properties of different shapes, it's all about the actual language. And so one of my favourite things to do is to get students to come up with their own definitions for different shapes. And then what I like to do is when they read me their definitions, I try and test them to see if there's any holes in them. So let's just say I wanted my students to go and write a definition for the word triangle. I might give them 3 minutes, then they'd write their definitions, come down to the floor, and then we test them out. And then, as they share their definitions, I'm purposely trying to see if I can find a loophole to break their definition so I don't draw a triangle. So, for example, if they said, a 3-sided shape, I might go 1, 2, 3. I've got 3 sides, 1, 2, 3. And then they might go, no, they've got to be straight sides. And so, okay, well, we need to include that in our definition. So then the next group might go, no, it's got to be a 3-sided shape with all straight line. And so I go, okay, cool, like this. 1, straight line, 2, straight line, 3, straight line. It's a 3-sided shape with all straight lines. And then another group might say, no, but it's got to have 3 corners. You've got to have 3 corners. That's only got 2 corners. And I go, okay, all right. 3 sides, 3 corners. We've got 1, 2, 3 sides and 3 corners. So now I've got a triangle. And then, of course, hopefully they start carrying on about this gap here and talk about, no, can't have any gaps. It's got to be closed. So it's got to be a 3-sided shape with 3 corners that's closed. So 3 straight lines with 3 corners that are all fully closed in. So now do I have a triangle? And hopefully they all say, yes, that is a triangle. So then you give them some time to go back and see if they can refine their definitions further, now that we've tested it and tried to find some of the different loopholes. And so after our discussion, our class definition could end up looking something like this: a closed shape with 3 straight lines and 3 corners. And then you also want to think about too, though, is that some students might add a bunch more information than they actually need. And we want to talk about our definitions. We need to avoid any loopholes, but we also don't want to add any more extra information that there needs to be. So, for example, in this definition, I could have also added the fact that it's got 3 angles. I could have also added that all 3 angles are always going to add up to 180 degrees. I could have also added information about different types of triangles, for example, a right angle triangle. And all that stuff is great to know, but really the importance of this task is to really trying to see, can we come up with a definition that boils our shapes down to their fundamental properties, and can we test them so that we know that those definitions are solid and we're not missing some key bit of information. And honestly, it's crazy how many students you'll have that would think something like this is a triangle, because you even see it all the time in shows the kids watch and things, that how many times there'll be a triangular-ish shape with curved edges where they'll label it as a triangle. So by having these definitions, we can really be clear on, no, while this is similar to a triangle, for it to be a triangle, they need to be straight lines the whole way through. Now it's your turn. Go math it up.